All right, hello everyone. So today I cannot be there with you, but I still wanted to get to teach you the lesson, and so we'll do that with the video. So if you've got your notes out, then we'll go ahead and get started. So today is 5/12/17, and this is lesson 11.2, and this is standard 52, and the title is Area of Circles. And sectors. Okay, so you should be writing all of this down with me, just like we would in a regular class. So today's lesson is just like yesterday's lesson. We're just going to replace the idea of circumference and arc length with area of a circle, and then these kind of pizza slice things, which are called sectors, as the title gave away. So just like yesterday, however much of the circle the central angle takes up is how much of the area it will take up. So it will feel very similar to yesterday's, just using area instead of circumference. So first, we're going to talk about what the area of a circle is. So we're defining sort of area of a circle. And the equation is one that I know you've seen before. I think it's probably even come up this year. And it is capital A for area is equal to pi r squared. So if you square the radius and multiply that answer by pi, you have the exact area of the circle that you're looking at. So we'll go right into defining the sector of a circle. Sorry, it's so slappy. It's really hard to write with a stylus well. Okay, so I'm going to sketch a picture of the area, well, not the area of, but just of a sector. And so assuming that is the center, then the area I've shaded is defined as the sector of a circle. And so if we were in class, I would ask you to take a second and try and brainstorm how we'll define that, because we can't just say a portion of it, because if I were to draw a random chord in and shade, it would not count as being defined as a sector. So specifically, it is a portion of the circle that uses two radii as its what we call bounds. So the definition is the region bounded by two radii of a circle. Okay, so that is the definition of a circle. So our goal this section is to figure out how to find a sector's area. So like I said at the beginning, it's going to be just like the idea from yesterday. So I'm going to say sector of a circle formula. And it is also going to just be a proportion. And it's exactly the same, one of the ratios is exactly the same as yesterday's arc length. So when I set up my proportion, if I am looking at this sector right here, and I'm going to call that point A, and that point B, then, and I'm looking for the amount of area that pizza slice also known as a sector, takes up, then, like yesterday, it will depend on how many degrees that specific arc AB is. So on the right-hand side proportion, we're going to put the measure of arc AB divided by 360. But now on the left, instead of talking about arc length and circumference, we're going to talk about sector and area. So it will be area of sector. And this sector is specifically, well, I need to label the center point, so we'll label that center point as point P. So it's specifically the sector APB that over the area of the circle, which is pi r squared. Okay, so again, the portion that the sector takes up over the whole thing is the same as how many degrees the arc is over the full degrees of the entire circle. So that is the plan. So let's do an example problem. Oh, sorry, I should pause and say, just like yesterday, also, if you want just the pure area of a sector, then you could cross multiply both sides by pi r squared. You don't need to write this right here part down. I'm just showing you algebraically. If you multiply both sides by pi r squared over 1, then the pi r squareds would cancel on the left, so you'd be left with just, now do write this part down, area of sector APB, and it will equal, and now I'm going to write what we have up on the left side, sorry, the right side of our equation, which is the measure of arc AB over 360 times pi r squared. So if you were to Google search what is the area of a sector, this is probably the formula that would pop up. But I'm going to always think about it as the proportion, because then I'm not memorizing a formula, I'm just justifying it mathematically each time. All right, so let's do an example problem together. So example number 1 says find the areas of the sectors formed by angle UTV. So here's the picture. The center of the circle is point T, and I'm going to draw in two radii, U and V. Sorry, there's kids at recess. That's the screaming if you hear it. And then I'm going to say the measure of that central angle is 70 degrees. I am also going to tell you that each of the radii have a length of 8. Okay, so now please pause the video and try and figure that out for yourself. Okay, so you should already have an answer on your paper, and now follow along with what I'm doing on the screen. So the ratio that I want is, I'm going to aim for the small sector first, the UTV, the one that involves the 70-degree angle. And so I'm going to set up the proportion, area of sector, sorry, very hard to write, over the full area of the circle, which in this case is pi 8 squared, equals 70 degrees over the 360 degrees. So I'm going to simplify some things here. So instead of area of sector, I'm going to refer to it as x right now. Then I'm going to rewrite the denominator as 64 pi. And then I'm going to simplify 70 over 360 into 7 over 36. So now I'm going to cross multiply and get 36x equals 7 times 64 pi. So 420 plus 14 is 434 pi, I believe. And then I'm going to isolate x by dividing both sides by 36. And I'm going to get, gosh, I hope my math is right. I'm going to grab a calculator to make sure I'm doing it right for you guys. Okay, I was wrong, not 434. This should be 448. And then I'll divide 448 by 36. And math equals, and I get 112 over 9 pi. And so that is the area of the small sector. Now, in order to find the area of the other sector, because we do have the larger one formed also, I could set up another proportion and solve, or I could just compute the full area of the circle minus 112 over 9 pi. I think that's what I'm going to do. So I'm kind of running out of space, so I'm going to use this corner of the screen and say that the area of the full circle is 64 pi. And the area of the smaller sector is 112 over 9 pi. And that should equal the area of the large circle. So again, a cool thing you can do with your calculator is if you've got your calculator, you can do 64 minus 112 ninths and hit enter. And if you do that, you get a decimal, but you can again hit math equals, and it spits out, I did 119. I have the wrong answer. Sorry. 64 minus 112 divided by 9. Math equals, and I get 464 over 9 pi. And so though that's the area of the smaller sector and the area of the larger sector. Awesome. All right. So the other idea that comes up in today's lesson is the idea of population density. And so population density is just the number of people you have divided by how much land area you have. So obviously the population density of New York City is much greater than the population density of Saline, but you have to take into account how much land space you have as well. So what I'm going to ask you all to do is open up to page 603 in your textbooks, and at the very top of page 603 it talks about using the formula for population density, and it's really straightforward. It's just number of people divided by the area of land. And so in today's lesson they'll give you circular shaped cities or areas to find, and then you'll be set with the lesson. So the homework assignment that I need for you all to take care of is page 606. It's going to be numbers 6 through 12 even, and then these additional problems: 16, 18, 22, 26, and 27. And so the final two problems I think are pretty tricky because you have to subtract off certain non-shaded areas, and it just is a more complex problem than the starting off problems. I will also say you're totally welcome to use a calculator, but again, I want all the answers in terms of pi, so don't put 3.14, the decimal value, into your answer. Leave the pi symbol in to give exact answers, but you're welcome to use a calculator anywhere you want. All right, I hope you guys have a great rest of the period. I hope your behavior is wonderful, and I will see everyone on Monday. All right.